All right, good morning, everybody. So I am Jennifer Johnson with the Safety Codes Council. I'd like to thank you all for joining us today. We have got Cody and Andre from Hilti here, and they're going to be giving us a presentation on Firestop. So we have a couple of housekeeping items before we begin. For those of you that would like to collect the continuing education credits from today, make sure that your screen name has your first and your last name. Because that's what I'm going through to double check registration, and that's what I'll be sending off to certification afterwards. If it's different, you can change it, or you can just message me privately and let me know what your first and last name is so that I can make sure that you get those credits. They do take a few weeks to show up, so you should see them in your account within 4 weeks. If you need them sooner than that, if you need to renew or something like that, you can reach out to our certification team and they can definitely help you out with that. We are going to mute everybody during the presentation just to keep it quiet. There tends to be some background noise and things like that. So we will mute you so that it doesn't disrupt. We are also recording the presentation, so we will have it available on the council website. There was quite a bit of interest in it, so if anybody you know wasn't able to make it, you can let them know that they'll be able to view it there, and that'll be on there within the next couple of weeks. At the end of the presentation, Cody and Andre will be taking questions. So we are going to ask that you leave the questions until the end. They do have quite a bit of material to get through, so that'll help it go a little bit more smoothly. And then at the end, we'll have them, you can put your questions in the chat box and we'll be happy to answer any questions that you have. So thank you so much. Thank you everybody for attending. Thank you to Cody and Andre, and I will pass it over to them now.
Excellent. Thank you, Jennifer. Can you hear me?
You bet. Sounds great.
Perfect. So first of all, thank you for hosting us. We're very happy to partner with Safety Codes Council. So special shout to Jennifer and Paul for organizing this. And we just wanted to thank everybody for participating. I know how busy you guys are, so it means a lot to us that you guys would take some time out of your day to attend this. My name is Cody Owens. I am the fire protection specialist with Hilti Canada. I've been with Hilti for about 7 years now, and my latest 3 years I've been the fire protection specialist. So I take care of Southern Alberta here, and I'm joined today by my colleague Andre. I'll let him introduce himself.
Good morning, everyone. My name is Andre Binetsky. First of all, I want to say thank you, Jennifer, for help to organize this event. Few words about me and my responsibilities. I'm new in Canada, came from Belarus 2 years ago. Back in Belarus, worked as an engineer and specialized in the power plant design. Then 4 years ago, I joined Hilti and have been working for Hilti as an engineer in energy and industry segment. And 2 years ago, September 5th, came to Canada and fortunately stayed with Hilti and now working as a fire protection specialist. So in my position, I provide technical support of our engineering product, dealing with the contractor, run lunch hour for the architects, mechanical, electrical engineers, and also support our sales team in North America. Thank you, everybody, for coming.
Perfect. And yeah, one of our main goals here at Hilti is to kind of bridge the gap between the designers, the manufacturers, obviously, the contractors who we work with day in and day out, and the inspection community to build safe, code compliant Firestop buildings. So that's one of our main goals at Hilti, and we'll get right into it here. So kind of baseline of fire stopping is based upon one globally applied principle for fire safety, and that is compartmentation of a building. So compartmentation is dividing that building into separate compartments with fire-resistant walls and floors to increase the availability of escape routes for occupants. So when we think about this in real terms, if we're looking at it in a multi-residential building, for example, if we have a fire that would start in unit 101, we want to keep that fire contained to its point of origin for a predetermined time, using both fire-resisted rated walls and fire-resisted rated floors, so that the other occupants of that building have enough time to use the route of egress to exit the building safely, and our firefighters have enough time to come in and put out that fire. So when designers are designing a building, they'll break up that building into subsections using both fire-resisted rated walls and fire-resisted rated floors. Just to give you guys some examples of good compartmentation that we've seen in the field, we've got two pictures on the left. I'm not sure how good the picture comes across, but on the far left picture, you can actually see a couple of occupants in that building a few floors above the fire, not even aware that there's a fire going on. So that's a very well contained building there, and that's a good example of fire compartmentation. Second example, New York Trump Tower. So this was a fire that happened in New York several years ago. This was a non-sprinklered building, and there was a fire that happened. The fire was contained to its point of origin long enough for the occupants to evacuate the building and the fire department to come in and put out that fire. And true to his nature, the owner of this building, Mr. Trump, tweeted out that it was a very confined and well-built building, and in this case, he was correct. Some poor examples of when fire compartmentation goes wrong. For example, in Grenfell Tower in London, this was a fire that happened in the middle of the night for a residential building, and it spread rapidly and quickly throughout that building because of poor fire stopping, and it resulted in several deaths. So what we're trying to do with good compartmentation is these examples on the left, and avoid these horrible life safety issues on the right. So we've got the concept of compartmentation. So our designers have built this building with subsections with fire-resistant rated floors and walls, but we do have areas in this building that allow for the spread of smoke and flame. So these areas would be unsealed or open joints. So wall-to-wall or floor-to-floor expansion joints or head-of-wall joints that we need to be looking at. Doors or enclosures that we will talk a little bit later about in this presentation. Gaps at edge of slab, or more commonly known in the industry as curtain wall applications for fire stopping. And then unsealed pipe penetrations, ducts, cable penetrations for cable bundles or cable trays, and then membrane or one-sided penetrations, most commonly known for outlet boxes or tub boxes that we'll see that have deteriorated our fire-resistant rated walls or floor assemblies. So these are the areas that are going to allow the spread of smoke and flame and need to be addressed with the fire protection products. I'll pass it over to Andre to talk about some of the regulations that we have in Alberta.
So yeah, let's start the most exciting part of today's presentation, which is regulation. There's a 4 main documents that regulate activities related to fire safety in new construction and renovation. The first one is National Building Code of Canada. As a model building code, it has no legal status until it's adopted by a jurisdiction that regulates construction. So in Canada, it will be provinces. This code forms just the basis for all provincial building codes. For federal buildings such as airports, military projects, we should follow the requirements of this code. All other residential commercial projects in Alberta should be designed and built in accordance with the provincial building code. It's something like National Building Code of Canada, Alberta edition. Latest edition is 2019. So Alberta is just committed to use National Building Code of Canada as a base document, and we just modify it to suit Alberta needs in regulating their design and construction. So the next document is National Fire Code of Canada, 2015. So building can be designed and built fire safe, let's say 30 years ago. In order to keep it fire safe, we should follow the requirements of National Fire Code of Canada. And the last one is regional and municipal laws and bylaws.
Perfect, thank you, Andre. Now we'll kind of go through some useful definitions that the Firestop community should be familiar with. The first of which being fire resistance rating. So this is the rating that's going to happen to the substructure, and it means the time in minutes or hours that a material or assembly of materials will withstand the passage of flame and the transmission of heat when exposed to fire under specific conditions of the test. So what this is basically saying is when a designer is looking at different fire-resisted floors and walls, there's specific conditions of a test that those will need to go through, burned, and timed to make sure that they pass this test for a duration of time. And when they have that test passed, it'll be passed by a third-party organization, and it will be adopted into different floor or wall assemblies. So they will have what's called a fire resistance rating. Other terms that we'll need to be more familiar with is the difference between combustible and non-combustible type materials. The difference being when they are exposed to flame, combustible materials will have the tendency to lose a lot of their mass. So materials like wood or plastic or insulation, we know are going to burn in the result of a fire test, and a lot of the time they're going to lose a lot of mass or deteriorate quite quickly. Whereas non-combustible type materials like concrete or brick or metal type materials, those are going to hold a lot of their mass and not necessarily melt right away in the event of a fire. Which brings us to our next definition that's quite familiar within the Firestop community, is this concept of intumescence. So it's a term that describes materials which are designed to expand significantly when exposed to heat. So when we're thinking about fire stopping, if we've got a combustible plastic pipe that's penetrating a fire-resistant rated wall, we know that pipe is going to melt quite early when that fire hits it. So we need a type of material that's going to expand and choke out that pipe so that it doesn't leave a hole where that pipe is melted. So the concept of intumescence is very familiar with the Firestop community, and we need to know when to apply this product on which type of applications. Another term that we use quite often is annular space. So annular space is the distance between the outside of your penetrating item to the inside of the hole. So oftentimes there'll be more than one distance, so a minimum and a maximum of annular space. And this is just because, you know, as much as the construction industry wants everything to be centered as much as they can, oftentimes that penetrant will likely be off center. So you'll have a minimum and maximum annular space when dealing with these types of penetrants. So we need to be familiar with this when we're dealing with fire protection and understanding the tested systems and what that language means. One term that I see that's actually misused quite a bit in the construction industry is the misuse of the term firewall. So not every wall in a building that's got a fire resistance rating is a firewall, and it's a very specific type of construction or application. And what a firewall means is it's a type of fire separation of non-combustible construction that divides a building or separates adjoining buildings to resist the spread of fire and has a fire resistance rating as prescribed in this code. The biggest thing about it is it's got structural stability to remain intact under fire conditions for the required fire rated time. So the concept of this wall is its own substructure. So if we look on the picture on the right, on the fire side of this of the wall, this whole building is able to collapse under that fire, but the non-fire side and the wall itself, because it's structurally intact, will remain separate and intact after that building is collapsed, protecting the non-fire side of this application. So it's got very specific requirements for this firewall, and we just need to know the difference between a fire resistance rating of say a regular gypsum wall versus what a firewall is, because they will have different requirements to them, which we'll get to here in a sec. So through penetration Firestop system tested to CAN ULC S115. So the most common term that we use is an F rating, which will be thought of as a fire rating or a flame rating to the community. And it's basically the test is the duration of time in which flames do not pass through the system. So if we've got a fire resistance rated gypsum wall, in order to achieve a 1 hour fire rating, no flames can pass through that wall for a 1 hour duration of time from the fire side to the non-fire side of that wall. So this is what we're going to see with the majority of our ratings. Another rating that we might see in some applications is both an FT rating, so a temperature rating. Now the temperature rating is the time of period that the penetrating Firestop system, including the penetrating item, limits the maximum temperature rise to 325 degrees Fahrenheit above its initial temperature through the penetration on the non-fire side when tested accordance with CAN ULC S115. So essentially what this is trying to do is limit the temperature rise from the fire side to the non-fire side, including that penetration. We'll talk a little bit more about these FT ratings and where we might find them in our construction projects here in Alberta here in a few slides here. So there's two major categories of Firestop that we will see in our projects, that being both penetrations and joints. A lot of the types of materials that we're going to see on our projects, and it's important to know how these how these penetrants react in a fire. For example, the most common one that I can show you to kind of contrast is a metallic pipe versus a plastic pipe, a combustible versus a non-combustible. So we know that a non-combustible pipe, in the event of a fire, may not melt, but it will transmit heat from one side of that assembly to the other side quite well. Whereas a plastic pipe, we know that in the event of a fire will likely leave a hole in that fire resistance rated assembly. So we need to make sure that we understand how these different types of penetrants react in a fire in order to provide the correct solution. Other penetrants that we might see in our construction projects: cable bundles, cable trays, insulated metal pipes, ducts or mechanical shafts, which we'll get to in a later slide, and mixed or multiple penetration. So our contractors on site, you know, they already have a hole in there, and the electrician, instead of making his own separate hole, decides to run his cables through the hole already created. So we have, you know, cable bundles and different piping running through that same opening created there. So we need to know what types of penetrants are on our sites in order to provide the correct solution for them. Now, if we dive into a little bit of the National Building Code, I'm going to give you some verbiage just to kind of provide some clarity as well. So when we're looking at penetration specifically, the code says it gives us two options. So penetrations of a fire separation or membrane forming part of an assembly required to have a fire resistance rating shall be. So our first option is going to be sealed by a Firestop, then that which subjected to the fire test method CAN ULC S115 fire test and Firestop systems has an F rating not less than the fire protection rating required for closures in that fire separation. So what this is saying is our first option is we can deal with that penetration with some sort of a Firestop that's tested to CAN ULC S115. Our second option is to cast that penetrant in place. So for example, to give you an idea of what this might look like, is if you've got a concrete slab, the code does allow for a pipe to be casted into that slab and not treated with a Firestop product. There's some ambiguity or loose language within this second option, in my opinion, because it's not commonly sought after in the construction industry, because it doesn't allow for any sort of thermal contraction for that pipe. So for the plumber's concerned, if the pipe is expanding, contracting, it won't be allowed to if it's casted into that concrete place. And then secondly, this kind of allows for the use of plastic pipe to be casted into the concrete. And as we know, if there's no Firestop product that's applied around that plastic penetrant, that's going to leave a void or opening in our fire resistance rated assembly. And it's not the code intent to allow for those kinds of things. So it's not commonly seen in the industry, but these are the two options that the code is kind of presenting to us. Now, one point specifically that I want to bring up in the National Building Code is in relation to combustible piping in Canada or Alberta. So combustible piping within the National Building Code Alberta edition talks specifically about the pressure differential of when we're testing. So I'll save the lengthy code language, but it specifically references with that the test needs to be tested with a pressure differential of 50 pascals between the exposed and the unexposed side of the fire resistance rated assembly. So what this means is in Canada, if when we're looking at our tested systems, they need to be passing this 50 pascals in order to be compliant with our code. I mention this specifically because our neighbors to the south have a testing criteria of 2.5 pascals. So this is a very different testing method and testing standard in the States. And if we are accepting, if we do see a tested system that's only tested to 2.5, it won't be compliant to our building code. So it's very important that when we're dealing with combustible pipe, that we understand that it needs to be tested with 50 pascals. Other language in the code that I want to point out as well is the FT rating, the fire and temperature rating that I mentioned before. So the language in the code, penetrance of a firewall, which we had referenced before, or a horizontal fire separation, which I'll talk about here in a sec, that is required to have a fire resistance rating in accordance with Article 3.2.1.2, shall be sealed at the penetration by a fire stop that, when subjected to fire test method CAN ULC S115, fire test of Firestop systems, has an FT rating not less than the fire resistance rating for the separation. So lengthy code language, but what this is saying is we've got two different types of fire resistance rated structures that will specifically require both a fire rating and a temperature rating. Those two applications are in our firewalls. So as I mentioned, that very specific type of fire resistance rated wall that's its own substructure. If we have a penetration running through there, we need to test it to both a fire rating and a temperature rating. And then the other area that we'll see for this is a horizontal fire separation, most commonly seen in penetrations of a podium slab between a parking garage and in a residential unit. So if we see a horizontal fire separation in our buildings, we need to understand that that needs to pass both a fire and temperature rating. So for example, if we've got non-combustible drainage piping through that slab from the residential down to a parking garage, we'll need to achieve that fire and temperature rating. To give you guys a bit of a visual of what that temperature rating might look like, we've got two pictures here. A picture on the left, we'll look at a fire rated assembly that's tested to temperature on the top side of that horizontal fire separation, or the non-fire side. So as you can see, there's quite a bit of insulation that needs to be surrounded for those non-combustible pipes. On the right, this is what I typically see a lot more in Calgary here is the treatment of that temperature rating on the fire side, or the bottom side of that horizontal fire separation. So you've got mineral wool that's been applied to that combustible pipe to protect the temperature rise from the bottom side of the fire side of that horizontal fire separation, transferring to the top side. So this is kind of a visual representation to give you guys as what you might be seeing out in the field there. Sprinkler membrane penetrations, I just wanted to touch on because there is some language in the code that I want to just provide some clarity on. So sprinklers are permitted to penetrate to fire separation or a membrane forming part of an assembly required to have a fire resistance rating without having to meet the Firestop requirements of sentences 1 to 3, provided that the annular space created by the penetration of a fire sprinkler is covered by, and I will always mispronounce this, but I'll try my best here, a metal escutcheon, or it looks like a metal plate covering that sprinkler line. So I want to provide some clarity here. So if we're looking at this language, if we have a sprinkler head that has that metal plate, the code language says that at that penetration, even if it's through a fire resistance rated assembly, does not need to be treated. However, this does not also encompass the through penetration sprinkler lines if they do not have this sprinkler head and metal plate. So sprinkler lines need to be protected with a Firestop product if they're penetrating through a fire resistance rated assembly, unless it's a sprinkler head with that metal plate covering the annular space. So hopefully that provides a little bit of clarity. The other application that I get a lot of questions from my contractors on is ducts with fire dampers. So the picture on the left shows us what a fire damper on a mechanical duct actually looks like. And the way I describe it is it's a shutter that will trigger at a certain point of temperature, and it will actually shut and close that inside of that duct to stop the passage of smoke and flame. So you'll see these on site. They'll have a little hatch at the bottom, and that's for inspection purposes throughout the course of the longevity of that building. So these types of applications, if that duct has a damper and it's installed as per NFPA 80, you will not need a fire protection material around that, Firestop material around that type of a penetration. However, if you have a duct without a damper that runs through a fire-resistant rated wall or floor, we'll need to apply some sort of a Firestop material to that application. So just hopefully that provides a little bit more clarity on that application. And then lastly, one of the big changes that we had as pertaining to fire protection within the 2015 National Building Code of Canada is a notable change to outlet boxes. So often referred to in the industry as membrane penetrations. So obviously, if we have an outlet box that penetrates a fire-resistant rated wall, it will deteriorate the rating of that wall. Now, there are exceptions to this, and I'll get them to a second, but the code language states that we do need to apply a Firestop product to this application, unless we meet 4 different requirements to allow for this exception. Okay. The code language is very technical and lengthy, so I will give you kind of a Coles notes for each one of these conditions in order to waive that fire rating there. So first is the size of that outlet. So the code language says 0.016 meters squared. I don't know about you guys, I can never visualize that very well, so we've translated it here. So it's basically a 25 square inch area, so a 5 by 5 inch outlet box. Next condition is an aggregate area of 100 square inches in any 100 square feet of surface area. So that second point, to kind of break that down a little bit more, it's how many outlet boxes you have in a certain area of rated wall. So if we have a box that's too large or too many of these boxes in that same area, these will need to be fire rated. The annular space between the membrane and the non-combustible electrical outlet boxes did not exceed 3 millimeters. So when we have our outlet box, we need to make sure that the annular space that's cut out between that gypsum does not exceed 3 millimeters. And in addition to the requirements of sentence 2, we need to make sure that the outlet boxes on the opposite or adjacent sides of the wall don't have a horizontal distance of not less than 600 millimeters or 23 inches apart. So just kind of a recap of this, you do need to have a fire protection a Firestop product around these membrane penetrations, unless you have all 4 of these areas covered. So that the box is less than 5 by 5 inches. We don't have too many boxes in the same area. The annular space does not exceed 3 millimeters around that outlet, and the outlets on adjacent sides of that wall are not less than a horizontal distance of 23 inches between the two. So I know that this can kind of cause a little bit of confusion, but hopefully that breaks down the code language in a little bit of clarity to when we do and when we don't require Firestop around those membrane penetrations. I'll now pass it over to Andre to talk a little bit about Firestop joints.
So thank you, Cody. So the next part of today's presentation is code requirements for Firestop joints. So on this slide, you may see some typical joint application. On top left, you see top of wall joint between the gypsum board wall and concrete over Q-deck. Here we have a castle cut. Just below that, we have a joint between the same assemblies, but in this case, the gypsum board was cut straight. And the Firestop solution consists of mineral wool and spray. Top right is a concrete block wall going up to the concrete over Q-deck above. And the bottom right is a joint between the concrete block wall and the concrete floor. So what code says here is much simpler and much easier than with a penetration. So requirements for the joints will find into the continuity of fire separation statement. It says the continuity of fire separation shall be maintained where it abuts against another fire separation, floor, ceiling, roof, or exterior wall assembly. So if you have a fire separation, it can stop 2 millimeters short of the next assembly, or 10 millimeters or 100 millimeters short. The fire rating has to extend all the way to the next assembly. So code doesn't allow any unprotected gaps between the assemblies. So top of wall, bottom of wall need to be Firestop. How we should do it? In accordance with Appendix A, we have to fill in all openings at the junction of assemblies with materials that will ensure the integrity of fire separation at that location. So in this sentence, basically code says to use Firestop materials to fill this gap. And we have a second requirement that say that physical characteristic of materials need to be taken into consideration. So basically we should use flexible enough materials to accommodate joint movements. So, and this is basically all we have in Canada Building Code related to Firestop joints. So in order to comply with the code requirements, next slide, we have to follow test standards CAN-ULC S115. And before we even run the test in the furnace, we check if the Firestop material is able to withstand 500 cycles of movement. This video shows the test of the joints between drywall and concrete over Q-deck.
After curing completely, is administered to the 500 cycles. This particular test here shows, similar to our UL listing, the 50% compression and extension. And you can note how well the material is adhering to the underside of the metal deck and the gypsum.
So when we ensure the dynamic integrity of the joint, we proceed with a fire test. So on the right photo, you may see the joint from unexposed to fire site. So we obviously don't want to see any smoke and fire passage through this joint. And also installed thermocouples measure the temperature conductivity of these joints for T rating. Next slide. This slide shows us what happens if inappropriate materials used, like drywall mud. It will shrink during curing, it's quite obvious. Also, this is cementitious materials. It's not very elastic, and it will crack even more under the load. And all these cracks is just a clear path for smoke, for toxic gases to come through. Just a few words about the testing. So before we declare that such and such product could be used to Firestop pipe or cable penetration through radiated assembly, it should be tested in accordance with certain standards. For Canada, it will be CAN-ULC S115. And this standard gives us clear guidance how to run the test, what is the temperature curve should be in a furnace, and all other necessary details. So next video show you the way we test our materials in our tested facility down in US.
Welcome to the Hilti Western Hemisphere Product Development Center. You're in our North America Firestop testing facility, where we test all of our fire protection products in accordance with UL CUL, and ASTM standards. There are 2 furnaces in this facility. The one on the left is used to test floor or ceiling applications, while the one to the right is for wall applications. The testing process begins in our prep area. In this example, the assemblies consist of plastic, insulated, and non-insulated pipe penetrations. Hilti Firestop solutions like FS1 Max and Firestop collars are installed around the pipes. Once the assemblies are built, we add thermocouples to measure heat transfer through the assembly and the pipes as required by the testing standards. As final touches are put on the assembly, technicians prepare the furnace and afterburner. The afterburner is a high-powered incinerator that burns the smoke and gases generated by the test itself. When it's ready, the assembly is carefully secured to the furnace. Lead wires from the thermocouples are attached to the monitoring system and tracked with our computer program. With a mouse click, the furnace's burners are ignited and the test begins. Within a few minutes, the PVC pipes and insulation on the fire side of the wall melt away, causing them to ventilate smoke into the room. Heat causes graphite in the products to expand, creating a seal that continuously expands as long as the heat is applied. This closes the pipes and limits the passage of smoke and harmful gases into other parts of the building. After 10 minutes, the temperature in the furnace is 1300 degrees Fahrenheit. The burn test can last anywhere between 1 and 4 hours, depending on the assembly being tested. As the last few seconds tick away in this 1-hour test, the temperature in the furnace is 1700 degrees. Our products have done their job to protect the penetrations and to keep the fire on one side of the wall. As you can see, there's not much left of the pipes exposed to the fire. The fire side of the assembly will now be subjected to a powerful stream of water. We use an authentic fire service hose and nozzle during the test. Distance from the wall, water pressure, and spray duration are all dictated by ASTM and UL test standards. As the water hits the superheated sheetrock, it practically explodes from thermal shock and impact of the water. This type of test helps determine structural integrity of the Firestop systems. As the charred wall disintegrates, most of the assemblies and leftover pipe go with it. But on the non-fire side, the assemblies remain in place exactly as designed.
So just before we get to that, the second portion of that test with the hose rating, just to provide some clarity, that's required in the States, but that type of a rating and testing standard is not required for Canadian building code. Sorry, Andre.
No, it's okay, thank you. So one question I always ask in contractor is, what is the hourly rating of our Firestop product? And often I hear 2-3 hours response. So the truth is that F rating of any our product is 0. Product itself can have any rating. Only Firestop system have ratings. And as an example, system on the left, CAG 2035 for plastic pipe penetration through the concrete slab. On this system, you may see not only Firestop collar, but all other elements involved in a test, such as rated assembly and penetrating item, and the system has a rating of 3 hours. At the same time, we could use the same collar, the same Firestop collar, to Firestop penetration through 1 hour rated gypsum board wall. It doesn't really matter how good our collar is. This system with gypsum board will fail after just 1 hour and few minutes, simply because the wall in this case is the weakest element of the system. So this is why products have no F rating on these systems. How we can find correct system for site applications. Next slide, please. We just have to find the system that match site condition 100%. So let's take a look at this example when 4-inch copper pipe running through 4.5-inch concrete slab. Slab has an F rating of 2 hours, and the annular space between the pipe and opening is 2 hours. So CAJ 1421 looks like right choice, and let's check if all the elements match the site condition. So first one is rated assembly, and the position number 1 in the system is concrete floor. Minimum 4.5-inch thick, so we're good here. Next is F rating. System was tested for 2 and 3 hours, depending on the concrete slab thickness. So okay again. Next one is penetrating item. You see multiple options listed, and one of it is actually a copper pipe, maximum 4-inch in diameter. Again, it match. And finally, last one is annular space, and the system provides 2 limits. So minimum annular space is 0. We're okay if the pipe has a point of contact with the concrete surrounding, and the maximum is 5 and 3/8. So we just have 2-inch, and it's within a system limits. After we confirm that all these parameters match with site conditions, we can use the system to Firestop the penetration. The rest is very simple. We just have to follow this system as a recipe. So what it says, it says basically that annular space needs to be tightly packed with mineral wool, position number 4, and then covered with just 1/4 inch of Firestop sealant, position number 5. When you've done these 2 steps, the penetration compliance with the system and code requirements. We have the same approach for the joint Firestop. As an example, the top of wall joint 1-inch width between concrete block wall and concrete slab. Step number 1 is to check the assembly listed in the system. Then F rating, system was tested for 2 hours. The reason we usually have joints is movement requirements, and we see that this system able to accommodate maximum 12.5% movements. And the last parameters is maximum joint width is 1-inch. As we see, system manages site condition and can be used to Firestop this joint. And again, all we have to do in accordance with the system is to apply just minimum 1/2-inch depth of sealant from both sides of the wall, and we're done. So our testing team runs fire tests in our facility almost every week. We just trying to cover all possible Firestop application, but it's impossible to test everything, especially for the renovation project. Some joints could be bigger than system limits. Some openings could contain dozens of different penetrants, and even if one tiny cable is not listed in the system, we can use this system here. So what we do in such cases, we need engineering judgment. We have a team of 20 engineers down in US who issued hundreds of EJs every week. So our engineers, they just follow the guidance established by the International Firestop Council, and every issued EJ is always based on the previously tested system. So it's important to notice that the purpose of EJ is find a solution for clients in the situation when that's not covered with existing UL system. If ULC system exists, match site condition, it's the only one available option, and we are not providing EJs just because somebody want to Firestop joint a different way or using another materials.
Thanks, Andre. So just looking at building inspection kind of best practices for Firestop, we took a lot of this information from the International Firestop Council website according to the inspections, but we've kind of summarized it in a couple slides here. So field inspection for when dealing with penetrations, the big one is document verification. So as I mentioned earlier with the 50 Pascal testing, we need to make sure that the systems that we're looking at are tested to CAN ULC S115. That's the a big starting point for this. Verify the hourly rating of our base assembly or our fire resistance rated floor wall assembly. So we need to make sure that if we're dealing with a 1 hour wall, we find a 1 hour listing. We have a 2 hour wall, and we need a 2 hour listing. Field install versus the listing. So making sure that the size of the opening does not exceed that which is listed in the tested assembly. Type of penetrant and wall thickness match the tested assembly, and obviously quantity of penetrants. If it allows for more than one penetrant going through the same opening, we need to make sure that that's verified with the tested assembly. Annular space we talked about before, so the minimum and maximum, and making sure that that's accurate to the tested assembly. And then the specifics. So what type of backing material? Oftentimes in fire protection, we have a backing material that's comprised of mineral wool. Making sure that backing material is applied to the thickness required by the system and also to the compression of the system. And then obviously sealant depth is a big one. And I kind of wanted to touch on this a little bit. So there's two ways that we can identify the fire protection ratings of these systems to the applications. One is with a visual inspection, where we look up and identify that Firestop material is there. But the other way that we can do this is with destructive testing. Now, with a visual inspection, it's incredibly hard to understand how much sealant depth is applied to a joint or penetration. And especially with the backing material, often than not, you won't actually see that backing material because it is covered with that Firestop product. So just understanding the difference between a visual inspection and destructive testing, and when it might be more advantageous or more necessary to do destructive testing is very important to understand. And then the quality of the products. I know this is a tough one to really enforce, but Hilti, for example, has two types of red caulking: CP606 that's got elastomeric qualities to it, and FS1, which has intumescent qualities to it. So they both are a red caulking type material, but react very differently in the event of a fire. And we do our best to educate our customers on, it's not just red goop in a hole. We need to be following the systems and making sure that corrective product is applied in the correct application. So verifying the quality of the products is important when we're looking at inspections on site. Very similar for the field inspections of joints. Verify that the documents is correct to the listing. The hourly ratings of both fire resistance rated assemblies matches the testing requirements of the tested assembly. And verify the movement requirements. So we do have some joints that are tested as static and some that are dynamic. So some that will move and some that will not have any sort of movement requirements. So if there is movement requirements on that particular joint application, we need to make sure that that tested system reflects that movement according to that job site application. Field install versus listing, sorry. So observe the nominal joint width and make sure that we're not exceeding the tested system joint width. And then the specifics, like we mentioned as well, the backing material, sealant depth, these are all big in ensuring that system is installed correctly. And then the quality of the products, which we mentioned before. So we'll quickly take a look at some of the maybe poor applications that Andre and I have seen on site, and just comment a little bit about why they are poor. So for example, we see this every now and then. It's the mixing of different Firestop chemicals. So Firestop chemicals should not be touching on site because we don't know often, a lot of times between manufacturers, for example, how these two chemicals are going to react. So if they're mixed, so we need to make sure that there's no mixing of these chemicals to ensure that those products are going to react the way that they should in the event of a fire. we've seen this before when you know our customers or our installers aren't necessarily educated, and they just think that they've got to fill the hole with something, and they're not looking at these tested systems. We've seen applications where we've got expansion foam or even a very misleading product that is out there is fire block expansion foam, which is obviously not a Firestop product. So none of these products are going to be listed in the in our tested systems, and they will not be compliant with the systems, and frankly they won't stop the spread of smoke and flame. They'll hinder it, and they'll burn very toxic gases as a result. So other things that we've seen on site, we've seen insulation, you know, just material, whatever they've got on site used to plug these openings. So obviously this is not going to be code compliant. Some of the applications that we've seen on site as well, this is kind of a bit of a red flag whenever I'm walking through with my customers to help them out. Anytime that we can see mineral wool exposed through the fire protection, Firestop product, we know that that's not going to be compliant with the minimum thickness of material applied on site. So on the picture on the left, we can see some mineral wool that's exposed through that product. So obviously we haven't had the correct amount of thickness of Firestop product there. And on the right as well, we can clearly see that there's mineral wool exposed on that top of wall joint. Whenever dealing with a spray type product, we need to make sure that we have both a minimum required thickness of material, and it will state in our tested systems that it will have overlap on two of our base assemblies. So it'll require that there's a minimum overlap on the block wall for ½ inch, and on the bottom side of that Q deck for ½ inch. So just be aware that if we can see exposed mineral wool through our Firestop product, then that's not installed as per the UL listing. And again, this is just a couple of examples why destructive testing is so important. We've seen backing material, anything from steel wool to even paper towel behind the Firestop material. So while it might look compliant on the front, you know, maybe that contractor didn't have the required mineral wool on site that day and just needed to use some sort of a backing material to apply behind the Firestop material. So this just kind of highlights why destructive testing might be more important to ensuring that system is compliant to the tested system. I won't spend too much time on this side. We call this the magic spray, you know, that contractor who thinks that it's all just red goop and I can apply it wherever, and I'm doing on my fire stopping. This is all combustible piping, and obviously this is going to be needed to be addressed with something other than just a spray type material in order to pass that test there as well. And one final thing that I wanted to kind of comment on that's a little bit, the code language isn't clear in the code, and I've had conversations with many contractors and actually the inspection community about this, is the transition of non-combustible to combustible piping through a fire resistance rated assembly. So oftentimes this is a kind of a quick fix for a lot of contractors that don't want to have to deal with the fire ratings of a combustible pipe. They'll transition right next to it, and while it doesn't specifically mention this in the code, it's not the code intent to allow this. We know that combustible pipe is going to melt, and it will create a chimney through that assembly. So bigger concept, this is all life safety. So this is, you know, code intent to make sure that this isn't acceptable, and we need to make sure that this isn't running through on a lot of our projects. What's wrong here? Obviously, there's gaps in that fill material. So, for example, a lot of the chemical products, because of their composition, will have some sort of a shrinkage in them, as minor as us as manufacturing want that to be. If there's not the appropriate amount of sealant depth applied during the course of construction, we can be left with these openings in that top of wall joint or penetration. So we need to make sure that obviously there's that correct amount of sealant depth to ensure that the Firestop product and system is compliant to that listing. Best practices. Won't spend too much time on this, but this is while these both look beautiful, I want to ensure that you guys know Firestop doesn't have to look beautiful, but with this, I mean, they've obviously tooled the picture on the left quite well, which is going to be a big point in our instructions for use when dealing with our fire protection chemical products. So, for example, once we've done applying that sealant, you're required from the instructions for use to use some sort of a trowel or putty knife or whatever to make sure that is a consistent depth, and that's what we really want. On the picture on the right, in contrast to the floor example that we had just shown, you can see that there's clearly no exposed mineral wool, so we've got the required material thickness, and we do have also that minimum overlap on both our block wall and metal deck assemblies to ensure that it's compliant with the code or the tested system. And then this is just really good practice that Andre and I are really trying to encourage a lot of our customers to start getting towards, and that's labeling of Firestop systems. So it obviously makes that inspection a lot easier when we know the tested system is labeled right next to that application. And for the future use of the building, if for the future use of the building, if there's any sort of rework or construction that's done 10, 20, 50 years later, they'll be able to come back and reference that tested system that was used in the original application of it. So this is really good practice that we are definitely encouraging with both our specifiers and contractors to be putting out in the field. So just to kind of give you an idea of what Hilti has to offer. So Hilti is the #1 Firestop provider worldwide. So we're not just local to Calgary and Edmonton or Alberta or Canada. We are a global company. We've got 2 fire protection specialists local to Calgary and Edmonton. I'm obviously in Calgary and Andre's in Edmonton. We offer Firestop training to a lot of our contractors, to the specification or the design community. We reach out to engineers and architects to do training with them, and obviously training to the inspection community as well. We have our own in-house fire protection engineers with specific engineering degrees focused specifically on fire and life safety. And we do create our own engineering judgments based on tested ULC or CUL systems and the IFC guidelines. Furthermore, we've got 30 account managers that are specific to the different trades within the construction community in Alberta here as well. So we've got plenty of boots on the ground to assist our customers with any questions they might have. And because we are local as well, we're able to do job site observation walkthroughs, not to be mistaken for inspections, but we will walk through job sites with our customers to offer guidance on how to build safe code compliant Firestop assemblies. Also wanted to say, again, a really huge thank you to the Safety Codes Council of Alberta for hosting us here. They've also done us a really, really big favor in promoting Firestop universities. These are specific to the inspection community. These will be in person in Calgary, Red Deer, and Edmonton through 3 dates in September. We encourage you to email out to Andre or myself if you'd like to sign up this. We'll be reviewing more in depth of the principles of fire stopping. We'll take a deep dive into code requirements, review alternative solutions or engineering judgments, and discuss more in depth on best practices. And we'll actually have any people that would like to register for this. They'll have the ability to actually get some hands-on training if they would like that. So that concludes the presentation right now. If we do have some time, I know we're just over our time limit right now, but again, we wanted to thank everybody who's attended, and we'll stay a little bit late here for some questions. I see there's some questions in the chat that Andre is looking at right now. And yeah, we just wanted to thank everybody for their time. Hopefully you learned something. And thank you again for the Safety Codes Council for having us here today. Just before we turn it back over, let's answer some questions. So we did have some questions that were submitted to Jennifer prior to this presentation. We tried to really leave as much product out of this as possible, but we did get one question that was regarding are there newer Firestop products in the market over the last couple of years? The answer to that is yes. Hilti is one of those companies that loves providing innovation to the different segments that we target on the construction industry, and fire protection is one of the big ones. So we call these types of materials preformed devices that take a lot of the installer incorrect installation out of it, and it also provides a lot easier inspections for the inspection community. So first of all, we've got two different products for gypsum to top of wall Firestop applications. That'll be a preformed device that we'll call Top Track. So we've got it for both flat concrete, and now we've actually got it for metal deck applications for the top of wall. And we recently came out with a preformed device for curtain wall or edge of slab applications that will be out in the field as well. So again, we didn't want to bombard with products here, but there was a question asked. So these are some of the newer products that have come out in the field in the last couple of years that you might be seeing on your projects, and we'll be doing a little bit more of a deep dive into the product side of things in our Firestop universities for the inspection communities. The next question that we did get, what is the maximum gap or number of cables before using a donut? So the real answer to this is it will depend on the tested system. So there's, as Andre and I mentioned quite often, there's a lot of different applications or different attributes that go into developing a tested system. Annular space, the basement, the fire resistance rated wall or assembly, the type of penetration, the sealant used. And just to give you an example, we've got 3 different products, for example, that you can use on cables running through a gypsum wall with 3 different tested systems that will actually give you different amounts of cable fill that you can use for different applications. So I understand where this question is kind of going, but I would always revert the answer back to the specifics of the tested system that the contractor has applied. So those were a couple of the questions that we got beforehand. Andre, have you got any questions in the chat there?
Yes. So first one is from Tim. What is the life expectancy of intermesh and fire stopping, and does water adversely affect intermesh and fire stopping?
What is the life expectancy of transparent? Does water adversely affect intermesh and fire stopping? So life expectancy, we design these products to obviously last for a long time, and it would be specific on the actual product. I can tell you we wouldn't put out a product that was going to last a year, for example, because a lot of these buildings are going to be built for the course of the next 50 to 100 years. We design these products to last through the longevity. As far as the life expectancy of each one of our products, I'll have to look into each one of our chemicals to see how long they are supposed to last. But if I can get a more of a concrete answer on that, I'll certainly reply back. And does water adversely affect intermesh and fire stopping? In some of our products, yes, we've got some products that are water soluble, where some are more silicone based. So if water is a concern on different job sites, There's different optional water ratings that we can achieve with our Firestop systems with specific Firestop products that are more of a silicone base that we can use in those types of applications.
Thank you. Next one. How does one clean out all product for new?
So if we need to, and again, that will be dependent on the product. So for example, if we're dealing with a acrylic based type product, often not, you can spray with the water and scrub pretty hard in order to get all that debris and stuff off, but it will be dependent on the product. Fire dampers require 1/8 of an inch for every 12 inches, so the damper under heat can trip. Some AHJs ask for this space to be fire stopped with intumescent fire stopped, and then it has to be removed. See ULC 555 for fire damper installations. I'm less familiar with the fire dampers, so I can't comment on them specifically. What I can say from a manufacturer standpoint is we won't have any tested systems for fire dampers, because if they're installed according to the manufacturer's instructions, then they shouldn't need a fire stop around them. So if a particular AHJ is looking for fire stop material around that gap, that will always be an engineering judgment from Hilti's standpoint. Thanks for attending, Bob. That's great. Appreciate it. Paul, combustible drain, waste, and vent piping is permitted on one side of a vertical fire separation, provided it is not located in a vertical service space. Yeah, good point there, Paul. I have to go. Thank you for excellent presentation. Thank you, Cody and Andre. Are Hilti looking into a device that can be used to measure the depth of Firestop sealant? To my knowledge, we don't have anything in development for. That's a very good idea, actually, Jason. But to my knowledge, we're not currently looking into a device that can actually measure the depth. But that's a very good point. If we could develop something that would limit the destructive nature of that destructive testing, that would be obviously a lot more helpful for the contractor when performing that destructive testing. So yeah, that's a great suggestion, and we'll certainly bring that up to the product management team to see if we can bring something like that out in the future to help these assessments and stuff. So cast in place is required to be non-combustible. Great, that's a great point there, Paul, as well. And he's got some code language that will back that up as well. So thank you for adding that as well, Paul. That's great. If anybody has any further questions outside of this as well, feel free to email Andre and myself, and we'll be happy to get back to you as quickly as we can on those. But once again, I just wanted to thank everybody attending for their participation and their time today. I know how busy you guys are, and one last thank you to Paul and Jennifer for hosting us today. We're very happy for the opportunity, and hopefully we brought some clarity to some Firestop questions that you might have had.
Excellent. Sounds good. Thank you so much for the presentation. It was wonderful. So again, reach out to myself, Cody, or Andre if you have any questions, and look for your continuing education credit in the next few weeks. So thank you very much. Have a great day.